guys, welcome to 10.2 on volume of cones. Let's get started. So the volume of cones, our learning target is going to be to find the volume of a cone, and our success criteria is going to be measured by our ability to use a formula to find the volume of a cone and use a formula for the volume of a cone to find a missing dimension. Okay? You already know how the volume of a pyramid relates to the volume of a prism. In this explanation, we're going to talk about how the volume of a cone relates to the volume of a cylinder. So a cone is a solid that has a circular base and one vertex. So if we were going to draw it, it would look something like that. It's got this circular base right here, and it's got the vertex right here, a nice pretty point, okay? So let's go ahead and we're gonna move on and we're gonna look at our first key idea. The volume of a cone V, the volume V of a cone is 1/3 the product of the area of the base and the height of the cone. So product means multiplication. So we're gonna find the area of the base, we're going to find the height, and then we're going to multiply those together, and then we're going to multiply those times 1/3. So V equals, whoops, sorry, I forgot to click on my pen. V equals 1/3 the area of the base times the height. And we do area of base because when we're looking for the volume of something, we're going to find how much this area right here, which is the base, how much we can fit in that. We want to know how much can I fit in all of this? And then we multiply it by the height because it keeps going up. Now, what's cool about a cone is we're going to multiply it by 1/3 because this cone is 1/3 of something. I'm not going to tell you quite yet what it's 1/3 of, but you need to know that this whole cone is 1/3 the volume of something else. Okay, so that's where the 1/3 comes in. It does come from someplace, and we'll talk about it. It's one of those things where I tell you in class, I don't want to give away the surprise before we get there. So, when we look at example 1, we want to find the volume of the cone. We're going to round our answer to the nearest tenth. So they give us this cone and they tell us that the diameter is 4 right here and the height is 6. Now we need to find the area of the base. So A of B, and we need to think back and remember that the area of a circle, this base is a circle right here. And so the area of a circle is equal to pi r squared. And that's where this comes in, okay? Let me see, kind of go over it. But that's where that B equals pi r squared, okay? And that's what this big capitalized B means. It actually means area of the base, like that, okay? So that's why they say that we can write the formula for the volume of this cone as V equals 1/3 pi r squared height. That pi r squared right there, that pi r squared right here is equal to the area of the base, okay? So let's go ahead and get started. Let's go ahead and just jump right into this. We know that the diameter here is 4, so that means our radius is 2. So we're going to have 1/3 pi 2 squared times the height, which is 6. So that's where all of our numbers come from, okay? And so really, this is where we get to start doing bigger math and we start to just use a calculator. So we say volume equals, I'm going to kind of do some of this. 2 squared is 4, 6, that's 24. 1/3 of 24 is 8. 1/3 of 24 is 8 times pi. So volume is 8 times pi. So then you're just going to use a calculator to do 8 times pi or 3.14. If your calculator has the pi function, it's always best to use that because that's going to give you a much more accurate answer. If your calculator does not have the pi button, then estimate pi to be 3.14. And you get 25.12. So we would say volume is approximately equal to 25.1. Now we're dealing with volume. Volume is always cubed. So we would say meters cubed or cubic meters. Okay, so now go ahead and do the try it. I want you to find the volume of a cone that has a radius of 6 centimeters and a height of 15. Round your answer to the nearest tenth. I am going to erase. And then we will look into this. Hopefully you paused and did the try it. So try it 1. We've got a radius of 6 and a height of 15. So our formula is going to be volume equals pi, 1/3 pi r squared h. So 1/3 pi 6 squared 15. 6 squared is 36. 36 times 15 is 540. 1/3 of 540 is 180. So volume equals 180 pi. It wants our answer to the nearest tenth. So I'm going to multiply 180 times 3.14. And I am going to get that the volume is approximately equal to 565.2. Now, I did all that on my calculator. I have my calculator sitting right here next to me, but I will verify my answer in the book. My answer says 156.5 centimeters cubed, and that's probably going to be because they used pi instead of the approximation. And honestly, I'm trying to find the pi key on my fancy dancy calculator over here, and I don't know where it is. So, oh, I found it. So let me try this again. Let's try 180 times pi. And yeah, that would be right. If I did it times the actual pi, it's due to the rounding errors. That's what happens when you round. I would get 565.486. So that would round to 565.5 centimeters cubed. Okay? All right, let's go ahead and move on to example 2. I hate not being in class with you. I hate not being able to stop right here and ask if there's any questions and solve any questions you guys have. I hate that I don't get to see your faces and see if you're understanding or not. It's honestly breaking my heart and driving me crazy. Okay, moving on. It wants us to find the height of the cone, round our answer to the nearest tenth. So let's start by writing our formula. 1/3 area of the base times height. Okay, in this one, they give us the radius, but they don't give us the height. And they also give us the volume. So we're going to start substituting, keeping in mind that area of the base is equal to pi r squared. So we're going to use this instead of this because they give us the radius. So we're going to say that the volume here is 956 is equal to 1/3 times pi times 9 squared times h. H is what we're looking for. H is our unknown. Okay, so just doing some quick math, I know that 9 squared is 81. 81, 1/3 of 81 is 27. So I would have 956 is equal to 27 pi h. Okay, that's where that comes from. And then I would do 27 times pi, and I'm going to get 84.8. So 956 is equal to 84.8 times h, and then I would divide. And so 956, and I'm actually doing this on my calculator, and I'm not going to round this 84.8 on the calculator. I'm just going to do 956 divided by the answer from the previous part of it I did, and I get 11.27. And so that means that h is equal to 11.27. They said to round our answer to the nearest tenth right here. So the final answer, I'll write it in red. H is approximately equal to 11.3. And this one, it's not cubed, it's not squared, anything like that. This is actually like a height measurement. It's just a straight measurement of something. So we would just write 11.3, and then we would write feet we would label it as feet, but it's not feet squared, it's not feet cubed, because this is actually the measurement of that height, okay? So now I want you to try it 2 on your own, and I'm gonna erase this, and then as soon as I get all of this erased, I will do the try it. All right, let's see. Again, I'm gonna write formula volume equals 1/3 pi r squared h. They said find the height of the cone to the left, round your answer to the nearest tenth. So the same thing, it's the exact same thing. We have 7,200 for our volume, 1/3 pi. Our radius here is 15 squared, and our height is h. 15 squared is 225? 225, yeah. So 1/3 of 225 is 75. So 75 pi h. Sorry, that's a terrible pi. So then 75 times pi is 235.6. 235.6 h. And then I would divide by that 235.6. This is just a basic equation. So there should be no problems once we get to this part. And we get that h is approximately equal to 30.6 with rounding yards. And that answer is correct. So I showed you the work and I verified it in my book. Okay? All right, so I hope this all makes sense. Moving on to example 3. Here it wants us to find the radius of the cone. So here you're going to notice that they're giving me my height and they're giving me my volume, but I have to find the radius, okay? So again, volume equals 1/3 base times height. Instead of base, we're using pi r squared because this time we have to find our r. So the volume is 80 equals 1/3 pi r squared. And then instead of h this time, we're going to substitute in 9 since we know that's our height. Okay? 1/3 of 9 is 3. So 80 equals 3 pi r squared. We can do 3 times pi, and we get about 9.4. So 80 equals 9.4 r squared. How did they do this? They did not do this like that. They did this a weird way. Okay, so let me see if my way works, because I got 9.4, and then I would divide both sides by 9.4. So I would say 80 divided by, and I'm not going to round on my calculator. So I'd get that r squared equals 8.488. Now to undo the squared, you guys know this, I would square root both sides. So on my calculator, I can hit second square root second answer, and it's going to plug that answer in. And guess what? I get that the radius is approximately equal to 2.9, which is what they got in their somehow weird way. I didn't even look at what they were doing as I was working it out. So let me look at what they did here. So they just divided by 3 pi, and then they square rooted the whole thing using a calculator. So if I plugged into my calculator second square root, or if you're using Desmos, just the square root equals square root, and then I did 80, and I would probably put this in parentheses, 80 divided by 3 pi, end parentheses, and then I'm going to get 9. What did I do wrong? Because mine gave me 9.15, which is what I got somewhere else for the answer. 80 divided by the square root of 80 divided by 3 pi. Let me try not putting it in parentheses. I wonder if my calculator doesn't understand this. I don't know. I like doing it this way. I like doing it my way over here, because then you can see all the steps. I keep doing that. I like doing it this way because you can see all the steps, and to me, this makes more sense. You see it all worked out. You do need to use a calculator to be able to do it that way, but I mean, they're telling you to use a calculator right here anyway, and I'm plugging 80 divided by 3 pi into the square root of 80 divided by 3 times pi. There we go. Okay, the 3 pi part, that's what it is. So when you plug it into the calculator, it's the square root of 80 divided by 3 pi. You got to put the 3 pi part in parentheses. So when I did that, it went ahead and gave me this answer. So that's why seeing it sometimes and learning how to play with it on the calculator is helpful. Okay, go ahead and pause and do, let's see. I don't know. Let's do try it 3. Let's do try it 3 that I'll explain. I want you to pick one, knowing that I just said I was going to explain try it 3. You're all going to pick try it 3, so I don't even know why I bother. So let's just look at try it 3. Find the radius of the cone around your answer. So volume equals 1/3 pi r squared h. Volume, well, not volume because we know what the volume is. So the volume on this one is 183 equals 1/3 pi r squared times 7. Okay, this is where it gets a little tricky. So I am going to do 7 divided by 3. 1/3 of 7 is 2.33. 2.3 pi r squared. And then I'm going to do r squared equals 183 divided by 2.3 pi. Square root both sides so that these cancel. And let's see. So second square root of 183 divided by, on the calculator, that's what's so cool about the calculator, is I can do parentheses second answer, and it's going to do the whole 2.3 repeating, and then I can do times pi and close parentheses, and it's going to give me a much more a much more realistic and close answer. So R is approximately equal to, and I got 4.9. What does it ask me to round my answer to? To the nearest whole number. So I got R is approximately equal to 5. So that's what would be 5 feet. And let me check the answer in my handy dandy book right next to me, and boom, I'm right. Yay! Yay! So I know all year long I've been talking about the need for you guys to have a calculator, especially a scientific one. It doesn't have to be a graphing one, but in high school you are going to need a graphing one. You're going to need a TI-84, something like that. TI-84. These are the ones we've used in class that you guys all like the yellow one and the black and white one. Go get one. See if they're on sale right now because we're in the middle of a pandemic and nothing is going right for anybody. But you're going to need a TI-84 in high school. I can almost guarantee it. I know that some of the teachers at CDO don't allow Desmos. Shout out Mr. Blauser. So you're going to need a TI-84. So try to find one of those, or it doesn't necessarily have to be a TI-84, but it needs to be a graphing calculator for high school. And I know they're a little bit expensive, but let me know if you need any help, okay? And they're really cool because you can hit that second button, and then the answer, which is your negative sign, and it plugs it into the calculator using your answer. Okay, so let's go ahead and go on now to example 4, modeling real life. It says you must answer a trivia question before the sand in the timer falls to the bottom. Each second, 50 cubic milliliters of sand fall. How much time do you have to answer the question? So we're going to use the formula for the volume of a cone to find the volume of the sand in the timer. So we want to know how much sand is in this timer. And we can see we're not looking at the whole cone here. We're just looking at this little piece of the cone right here. Okay, so we're going to write a formula. Volume equals 1/3 area of the base times height. And then we know that we can sub V for pi r squared. So V equals 1/3 pi. Our radius in this case is 10 So 10 squared times the height right there that we see is 24. Okay? So 10 squared is 100. 100 times 24 is 2400. And a third of that is going to be 800. So we're going to have V equals 800 pi. Okay? And we're just going to leave it right there for a minute. That's the beauty of pi, is when they say leave your answer in terms of pi, you just leave the pi alone. So we know that the volume of the sand is 800 pi cubic meters, and we're going to use the rate at which the sand falls to determine how much time we have to answer the question. We know that each second, 50 cubic milliliters of sand falls. So what we're going to say is we're going to say 800 pi millimeters times cubed 1 second every 50 millimeters falls, okay, cubed. And then we're going to have some things kind of happen here. These are going to cancel each other out. So we're going to be left with 800 pi times 1 over 50, okay? And this is something that you could plug into a calculator. 800 second, the caret key, which looks like this on the calculator. So 800 pi times parentheses 1 divided by 50, because that means 1/50th, and you get that it's approximately equal to 50.27. So that means seconds. Notice that our seconds did not cancel out. So you have approximately 50 seconds to answer the question. Okay? So I hope that this video helped. Please let me know. I sincerely hope that you guys are watching these videos and I'm not sitting here for 40 minutes recording myself just for the heck of it. Please let me know if you have any questions. You know how to get a hold of me, you know all my different ways, and I hope to see some of you really soon on a Zoom meeting because I miss all of your beautiful faces. Oh my goodness, I've been teaching math too long today. I miss all of your beautiful faces.